Hello and welcome to this video. We're going to be talking about simplifying radical expressions. This is lesson number 5. Here's our agenda. We're going to start with our objective, talk about the new material, try some practice problems, and I'll leave you all for some IXL to do on your own. Here's the objective. Students will simplify radical expressions. I'm going to talk a little bit more later on about what is a radical. And again, our big idea is polynomial functions. Okay, so here's our overview. We're going to take complicated expressions with radicals. Here's what a radical is. This kind of check mark looking thing. You would call this a square root, a cube root, so on and so on, but we can write any number there. And just keep in mind, square root actually has a 2 there. These are called radicals, and technically they are polynomials. So we're going to learn how to simplify them. Here's an example of what we're going to do. We're going to take an expression like this, and we're going to simplify it to its equivalent expression like this. So let's get started. To begin, we need to establish some important radical rules. If you have two expressions like this, and you multiply them, for example, x squared times x to the third, your result is going to be those two exponents added. And actually the reverse is true. So x to the fourth is the same thing as x to the third times x to the 1. I can split it up as well as combine it. Another thing we need to know is that the nth root is the same thing as x to the 1 over n. So for example, the square root, which you can remember has a little 2, is the same thing as x to the 1/2. And similarly, the cube root is the same thing as x to the 1/3. So on and so on, we're going to be using that rule a lot. So here are the steps we're going to use to solve these sorts of equations. We're going to start first by rewriting the expression with a fraction exponent. Then we are going to distribute the exponents to both terms. Then we're going to simplify the number in the variable. However, if we can't simplify, we may have to split up using that exponent rule we just talked about. And then lastly, we're going to write our answer and leave any unsimplified terms under the radical. So let's try our first example. Step 1 says rewrite the expression with a fractional exponent. So this is really square root with a 2, so I can rewrite that as 900x squared to the 1/2. Alright, step 2, distribute the exponent to both terms. So I'm going to distribute that to 900 and distribute this to x squared. So I'm going to get 900 to the 1/2 and then x squared to the 1/2. Now 900 to the 1/2 is equal to 30. And x squared to the 1/2, well, we just multiply these two things. 2 times 1/2 is a whole number, that's 1. And so I'm going to write it like this. Now you'll notice that I put absolute value signs. That's because if the radical has an even power, so 2, 4, 6, 8, so on and so on, then the answer outside of the radical must be an absolute value. I'm going to talk more about this later, but this is actually our final answer, and we can rewrite it without the little 1 there. It just says 30, absolute value of x. But notice the 30 does not go in the absolute value, just the variable. Let's try another example, and on this one we're going to need to remember our perfect squares. So let's rewrite this. This is the same thing as step 1 to rewrite with fractional exponent. So that's to the 1/2. Then I'm going to step 2 distribute to each of these two terms. So I get 98 to the 1/2 and x to the 14th to the 1/2. Now if you put 98 to the 1/2 in your calculator, you're not going to get a whole number. So this is where we got to use our splitting trick. 98 is actually going to be the same thing as 49 times 2. X to the 14th will actually simplify because 1/2 times 14, that's just 7. So we get x to 7, and then remember, since this is even, it has to have an absolute value sign. Now over here, we're going to redo the distribution again, and we're going to get 49 to the 1/2 times 2 to the 1/2. And then of course we still got our absolute value x of 7. 49 to the 1/2 is 7. 2 to the 1/2 does not simplify. So that is one of the terms I'm going to have to leave under the radical. So this is going to be our final answer. I know it looks complicated, but that's the answer. Alright, let's try this one. Again, we're going to have to use our splitting trick. Let's first start by rewriting with a fractional exponent. Alright, now if I multiply 22 by 1 over 5, I'm not going to get a whole number. So I need to split 22. And here's what I'm going to do. I'm going to write this as negative x to the 20th and negative x to the 2. And again, that's multiplied 1/5. I mean to the power of 1/5. So I distribute this to both things, and now 1/5 and 20, those will cancel because 20 divided by 5 is 4. So I'm going to get negative x to the 4th. Notice this is an odd power, so don't have to write the absolute value. And then this is going to just stay under the radical like that. Now that's going to be my final answer. And let me rewrite it so it's cleaner. Negative x to the 4th times the 5th root of negative x squared. All right, let's try one last one. Again, I'm going to start by rewriting with a fraction. Okay, now I need to distribute this to both terms. So 4 to the 1/2 times x plus 5 to the 5th, all that to the 1/2. Now 4 to the 1/2, that's just going to be 2. But this one over here, I'm going to have to split up because 5 and 1/2 don't go evenly into each other. So I'm going to just take 1 away so that I get to 4. That's going to leave me x plus 5 to the 4th times x plus 5 to the 1, but I'll just write x plus 5. Now if you're wondering how do I know what to do, you're just looking for the closest number, which in this case was 4, that will divide into your fraction. So 1/2 goes into 4, so I knew I only had to take 1 away. So that's why I did that. And again, there's 1/2 over here. Distribute, and I get 2 x to the 5th to the 4th times 1/2 is actually x plus 5 squared. And that has absolute value because this is an even radical. And this last x plus 5 is going to remain under the radical. But now here's something tricky. Even though this is absolute value, this is an even number here, which means I can actually drop the absolute value. And so my final result is going to be this. Now that only works if at the very end, this final exponent happens to be an even number. In the previous examples, it was an odd number, but in this case it's even, so this is my final answer. Alright y'all, so that's it for this lesson. At this time, go ahead and complete this IXL Algebra 2 L4 on your own. If you need help, please email me with your question or join me during my office hours on Zoom. Best of luck.